So this video is on using a very low spec Ubuntu VM to provide routing and firewalling to an Azure subnet and virtual network, and it's just going to go through all the small details required to get it working and getting connectivity reasonably securely. So what we are going to start with is just confirm our settings for our firewall. Now in our firewall we have two network interfaces. One is in a WAN subnet and the other one is in a LAN subnet. But it helps as you start to configure things if we just make some notes. So what I'd like to do is just say, okay, I want to just make a note of the IP addresses for the WAN addresses, and you do that by just having a look at the configuration settings, and you just get the private and the public address on that WAN interface. So that's the WAN interface. Then we might have a look at the LAN interface, which is the back-end network interface here, and we can then copy the IP version 4, and then we've got an IP version 6 configuration. Now, one thing that's vitally important that we always want to check is that on the LAN network interface that IP forwarding is enabled. If that's not enabled, you'll have weird non-connectivity issues because the Azure platform will not forward packets through the interface from different hosts in the back end. So get that set correctly, and there'll be less hassles when you go to sort things out. Now let's get connected to our firewall. Now to do that, you go down to the connect menu and just select that, and then you'll have a connection string here that you can copy, and in my case I've got a public key loaded in my SSH agent. So when I have that added, I can remove the key path to the private key and just connect, and my virtual machine has my public key, so it lets me straight in. So we're now connected successfully to our firewall. The first thing you can do is just do an update of the package lists to get the latest packages for your firewall to make sure that you got the latest security patches installed. Now this happens on ultra low spec VMs. You notice the word killed at the bottom of the screen here. What that is that you've hit the hard limit for memory. So we're going to work around that. So if we have a look at our free command, we see that there's no swap available. And so if we look at journal control and then we grep for the word killed, it'll tell us why that's happened. So it's saying out of memory, a process of this unit has been killed by the out of memory killer. So to work around that, we want to add a swap file. There's a lot of different ways of doing it, but the one way that we can do it is just create a swap file and then load it into our etc fstab file, every file system table, and it'll add it every boot. Or we can use a script that Microsoft provides to create it and put it on what's called ephemeral storage. So just to show you what ephemeral storage is, if we sudo ls block, list our block devices, that SDB volume here, that's ephemeral storage. So we're going to create a swap file on there to get out of our resource starvation issues. So to do that, we can go, and I might just copy that in, it's a bit easier. Here. So what we're going to do is we're just going to create a swap script which Microsoft provides, and just not very good at mouse usage sometimes, but there we go. So we've copied our script, which is basically, it just says I'm going to make a swap file 30% of the size of the ephemeral disk, and then create it and give it the right permissions on, and it'll check every boot that it's there, and it turns it on. So once that's created, we just need to mark it executable, and then execute it. And it takes a little while to create the disk, but once that's done and it's mounted as a swap partition or a swap file, you won't get the out of memory killer killing processes when it uses a little bit too much RAM. So that is the first thing we want to do to make sure our very, very underspec'd virtual machine can continue to function, even if it runs out of memory. So we're now the happy recipients of some swap space. So that's solved that problem. So the next thing we might do is install etckeeper. So this basically is a program that will keep track of any changes in our etc directory. And so we're going to be making a lot of firewall changes, so it's a good idea to put it under version control so that we can roll back, and if there's any non-advantageous changes, we can sort of roll back to the previous version and reload the firewall, and recover quite easily. So this takes a little while, but once that's done, we can very easily keep track of changes. Right, so once that's completed, what do we need to do? Let's have a look at what our firewall is telling us. So this is the Uncomplicated Firewall. So if I enter status, it just tells me it's inactive. So the first thing we want to do is mark our firewall as being enabled. And one thing we don't want to do is lock ourselves out. So I'm just going to create a rule to make sure that I can always access the firewall. And we made a note of our WAN private IP address here, so we're going to do that and just say protocol TCP port 22. So I'm just adding that. Now we want to do the same thing for IP version 6 because we're dual stacking and it's that one. So we go back to here, and that's the private IP address of the WAN interface. And now we want to put in the IP address of our computer here as well. So if we now go status, we won't see anything, but we're reasonably confident that if we now enable our firewall, it'll be okay. Now if we go into our etc directory, and we can see that we've got initial commit, and then if we say, well, what's changed, from that we can see that we can now start to see all the different changes as they start to occur. So we could then say, okay, I want to commit my changes, firewall enabled, and then from that point on, say git and log, we can see that we're starting to develop a history, and we know what we're doing with the changes. So we've now, if we have a look at our sudo fu status verbose, we've now got two very explicit allow actions, and that will basically only allow SSH connections from these explicitly defined hosts. But there is something that we need to also look at. If we go back to our portal and go into our network settings again, we also, and we want to change to our WAN interface. We've at the moment only got SSH open, but I want my firewall to be the firewall. So I'm just going to create a very open rule, so an any rule basically. Any protocol, any port, any IP basically, and just say add. And it warns us that there's risks to that, but if you set up your firewall correctly, then the firewall will do the firewalling. So that's now an allow any rule. So that then allows us to just forget about the network security group, so we don't have to put rules in two places. Now that's got us working there. Now in this verbose output with an enabled firewall, notice that deny, anything coming into the firewall is denied. Anything outgoing, so from the firewall to anywhere, is allowed by default. And here we see that our routing, or the ability to route packets between interfaces in the firewall, is disabled. So we now want to enable that and make the changes necessary to make that work. So if we go into etc UFW and go into sys control as root, we have this option to uncomment these lines to allow host to route packets between interfaces. So we want that because behind the firewall are hosts we want to route to. So if we then look at verbose again, we can see it's still disabled, but if we now say reload our firewall and then go to verbose, now we see that by default routing packets between the interfaces is denied. So you're not going to get any packet flow from this interface through this interface or vice versa at the moment. So we're just going to change that to, if we have a look at our git and look at our diff, we can see the change there, but now we're going to make another change. We're going to say UFW default, and we want allow forward. And if we now have a look at the git change, we've changed our etc default UFW file, we've changed it from drop to accept. And if we have a look at our verbose output for our firewall, we can see now that anything traveling between interfaces is allowed. Okay, so now the next step we want to do is we want to start enabling both natting our traffic from our VMs, outbound, and also port forwarding from our public IPs to selected ports on our internal hosts. So to do that, we need to make some changes. If we have a look in the etc UFW directory, we've got before.rules and before6.rules. So those files need to have some code put into them so that we can do natting. So here we have our rules for our IP version 4. Now we want to firstly double check what our IP address is for our internal IP address is for our web server. So I'll just say our web server is that, and the IP version 6 is this address. And then we want to go and make sure that our addresses are correctly specified. So what we've got here, we've got port forwards to multiple ports to the same port on our web server, and then we've got a port forward from a high port to the SSH port on our web server. So this allows me to SSH into the web server from the internet. And then finally, we have a rule that says anything from this subnet that's going out the WAN interface will be masqueraded. Let's just have a look at those interfaces. So our ETH0 is the WAN interface. So that's the WAN interface. Our LAN interface is ETH1. As you can see, this subnet here is the LAN subnet, so we can say that's ETH1. And that become important later when we start allowing and denying forwarding and routing. Alright, so now we've got those interfaces identified. What we want to do firstly is apply these rules, NAT rules, to our, and we might just, right. So we want to make sure that we have a commit statement and all the appropriate rules, and we just need to paste them in. Now, the documentation says that we, like the Ubuntu server documentation says that we paste them in after this heading and before the filter rules. So that's our IP version 4. Now we want to do IP version 6. Now let's have a look at IP version 6. Now again, it's the private IP addresses of the web server. So just making sure that that's still correct. Looks right. Yep. So, and then we've got our subnet that we're going to masquerade, and then we pop that all in to this spot here. So once that's done, we can then reload the firewall, and if everything's right, we should be able to connect to the public IP addresses and get something back. So we've got the public IP address for IP version 6. Okay, so that's our Nginx server there, and then we want to do the same thing again, and we can just delete that IP version 6 address. So then we're getting something back from our web server on IP version 6. Now to check it for HTTPS, when you first try to do that, it says it's not trusted, but if you put a -K in, it will then just ignore the untrusted certificate and allow you to connect. So both our port forwards to our ports are working. Now let's have a look and see if our NAT and our redirection from a high port down to port 22 is working. So we can just go SSH, and we want to log in as Azure user on port 7322. So our port redirection's working as well, and might want to try the same thing again on Azure user on port 7322, and Right, so we now have that working successfully on SSH as well. So that's basically working quite well. Let's have a look from outside. So we'll connect and see if we've got an ability to ping an IP address and then maybe ping 6 for Google, and it's working. Now the other thing we would like to check as well is that another protocol other than ping is working. So, and we can try that by saying, well, we want either IP version 4 or IP version 6, and as long as both of them working, we've got traffic going in both directions. That's good. Now this, you think, oh, this is great, we've got no issues there, but one thing that is an issue here, if we go UFW status and then show our rules, we're actually allowing any forwarding through. So if there's, at the moment, if we have a look at our rules, we're just saying, well, anything that's coming in ETH0 on port 7322 or these other ports here, they're all getting forwarded. So that's a bit too open. So what we're now going to do is just change our routing so that we're more explicitly allowing and denying. So if we change things, if I log out of the web server here, and then we're going to make a change to the default, and we're going to say deny forwarding again, and basically, I don't know if you need to do this, but I'll just reload the firewall. So basically now it's not going to work because we've just started to deny the rules. So where do you go to see if things are being denied? You can go into var log UFW log and just tail the log, and sometimes it's a bit hard to see because there's a lot of traffic. But if I just cancel that and then highlight one of these, so that's my public IP address here locally, and then its destination is the private IP on the VM, and the destination port's 22. That we can see is now being blocked by the firewall because we've made a change, as we can see, to this, to deny routing. So now what we have to do is configure the firewall to explicitly allow certain things through, and make sure that only what we want, only the traffic we want goes through. So how do we do that? Well, we have a whole heap of rules that we can add to. So what are we trying to do? We're trying to basically saying this is what we want. So we want to create some rules to make sure that only explicit traffic is allowed, and the difference is that we're not specifying rules that are attaching to the firewall or in or out from the firewall. We're actually saying what can traverse across the interfaces. So we have to use this root command here. So we want to say root allow, and then we're saying when traffic's going in the Ethernet 0 port and out the ETH1 port from IP to this, then allow it. So I'm going to create some very open rules with this. So I'm going to say from the remote client IP, and the web server private IP address is this one, and then I want it the same thing on port 443, but then I want the same thing on IP version, and again, whoop, then port 80 as well. Now that gives us the rules we need to enable any access from anywhere to the port 80 and 443, and typically that's what you do on both protocols. So we can just go back to our web server, apply those rules, and then just have a look at whether that's working. Let's have a look. Have we made a mistake? Let's have a look at so allow. Now we may have made a mistake there. Why is that? Let's have a look. Yeah, we definitely have. We've basically, and this is why it can be a good thing to double check your rules so you don't get them incorrect. So we just want to make sure that those rules are correct. So we've made a mistake. How do we fix that? How do we delete rules so that we can make sure that we're not got old rules hanging around? So if we go status numbered, what we'll do is we'll get a bunch of different rules, but the numbers for them. It makes it a lot easier to delete. So I want to delete 2, 3, 5, and 6. Now I can't just delete them. I can't say delete 2, 3, 5, and 6. I can't do that, or it won't work. So what you've got to do is just say, okay, I want to delete rule number 2, and say yes. Now it's a very bad idea to delete rules in multiple delete statements. You want to just delete the rule, redo the status numbered, and then each time you select delete, so you don't make a mistake on deleting the wrong rule, because they do shift, obviously. Alright, so we've just fixed that problem. Now we need to go back and say to ourselves, well, we want to re-add all these rules. Now there's also a rule here I want to add to go from here. So I'm going to say from here, and is that incorrect? Have I done that wrong again? Let's just double check. It's 5, that's good. Alright, so I want to say port 22 TCP protocol TCP. Now you could add these explicit more explicit for these other ones as well. So you could say make them all very explicit, and we want to make sure that want that only enabled from the ports that we explicitly say that we want, so that we don't have, you know, unexpected access by evil hackers. Okay, so that looks, let's have a look at the UFW status. So in theory now, we should be able to connect back up with both all our different ports and get a web page from there. And then of course SSH in as both IP version 4 and IP version 6. So now that that's done, what else do we need to figure out? Is everything working the way it should? You'd think so, but let's now SSH into our web server, and I'm just going to try and connect from my web server out to a web page on the internet, and as you can see, it's working when it's port forwarded from the outside, but it's not. I can't connect to anything going out the other way. So what is the issue there? Well, again, we could probably just have a look at the firewall here and go back to here and have a look and say, oh yeah, so yeah, so we're seeing that basically we've got it's blocking traffic going in, going out. So in the ETH0, out ETH, in ETH1, out ETH0, coming from the web server. These are expanded IP addresses here, so they're a bit harder to read. On port 443, it's being denied. So now we need to add some rules out so that we can get outbound routing working. Now, so we're looking for, let's have a look. This is my issue. I've got too many notes from previous playing with things. All right, so that allow. So we want to create something like that. So we want to say we want to allow anything coming in the LAN interface and out the WAN interface from the specific subnet. So let's go grab our web server subnet. I'll just allow it. And we want to do the same thing in both protocols. So from 0 / there we go, 24. So let's see if adding these two firewall rules now give us outbound access. It does. So we've now basically got connectivity in both directions, and if we want to see our rules as we've been adding them as they're added, we just want to go UFW show, and we want added, and that will give us all the commands that we've run so that we can copy them away or modify one to make it work for us. Now, what do we do if we want to deny from a specific host? Like maybe we're looking in our firewall logs, and we've got a server that's basically hammering our ports or trying to hack us. Look at the example here. Someone's trying to connect from, let's say that IP address, we wanted to deny that IP address. So we wanted to deny it being forwarding it, or we could say, so we'd say sudo UFW route deny in on ETH0 from. Now, would that work? It looks like it would. So you don't always have to be fully explicit if you don't want to, but just have a look at that deny. Notice where it is. That's not going to work. Why? Because we want that to be very early in the status numbered. We want that deny to be the earliest of the forward statements. Maybe we want that. So we're going to now say sudo UFW delete 6. So we're just denying that, deleting that, sorry. And now we want to go, okay, FUW root insert, and we want to insert it. Where do we want to insert it? Let's insert it at position 2, and then just have a look at that there. So we've now moved the deny statement to be above any except statements for forwarding, and we now can be confident that this host is not going to be allowed in. Can we insert that statement? Can we delete that statement and insert it above the allow statement? Let's have a look. We're going to delete that, and then let's now insert it. Have a look. Yeah. So it looks like and there's another weird thing with this. If I delete that again, and now look at everything numbered. Now let's try and insert it at position 8 and see what it does. Right, so what that's basically saying is the rules are grouped IP version 4 and then IP version 6. So if you try and insert a rule into the 8th position, which is in the middle of your IP version 6 rules, it will just say invalid position. So you need to specify to insert a rule in the proper area, the group, the IP version 4 or 6 groups. So that just means that there is a bit of a caveat with putting rules in. So that is how you get everything working in your firewall to get traffic going in and out. Now, our next challenge is, if we have a look at our image, we've got a dev machine over here, and we're just going to connect to it and just have a look at getting outbound traffic working. Clearly we can do all sorts of different things we might forward SSH to it as well. So let's have a look at that. So we're going to etc UFW, and because it's pretty much the same, we won't do IP version 6, we'll just do it in IP version 4. So what I want to do, I want to grab this, and I'm going to say 7.422, and I want to go across to, I think it's 8. I think the IP address, let's double check that. The dev IP address, the internal one, is 2.4. 2.4. Now the other thing is we want to make sure that we have masquerading as well. So we want outbound traffic to be natted for that subnet, and then sudo reload to reload those rules. And if we want to look at like how these rules are being added, we can then say, well, etckeeper, or you could even go sudo git status and go git add it's the same thing. You can do it with etckeeper or alright. So that obviously doesn't work because I need to change the firewall rules, but if we just do the same thing in it, maybe it's okay. Alright, now, so we now want to SSH to our dev box, but we've already got the rules set up. But if we try to, let's see if this works, but I don't think it's going to. So if we just, there it is, and it's 7422, wasn't it? So as you can see, currently we can't SSH into it, even though we've set up a port forwarding rule. And there's a few reasons for that. Firstly, if we just have a look at sudo show added, we need to configure a route to allow that. So we want to go, let's do it on this one. So we see we can copy here, and we want to, from my host here to, all right, so can we, so still not working. Now what's the issue? Well, let's log ourselves into the dev machine from our firewall, and we're just finding out that it's saying permission denied public key. Why is that? Let's exit completely. What happens is, if you have a look at SSH add, I've got my private key loaded in my SSH agent here, but it's not being passed through to the remote machine. So I'm going to say enable agent forwarding here, log into our firewall, and then attempt to jump across to the dev machine, and it worked. Now notice here we can try and ping stuff and it's just not working. So we need to, on our dev machine, we need to make some changes to enable the ability for the dev machine to connect to the internet. And it's because of probably circular routing maybe, but what I think it might be is that this Ubuntu box, the default route is to this IP address here, and this computer here is trying to connect here, and you're getting a sort of a circular route, but you need this Ubuntu box to understand that to get to this host in the back here, that it's got to come out this interface. So we're going to now make a change to allow that to happen. Now let's have a look at what that change needs to be. So the Microsoft documentation says that we need to create a file to turn off network auto configuration and a file change to the cloud init YAML. So let's do that. So we go here and create a new YAML file with just network disabled in it. So that's that first step. Then we want to go into our 50 and want to go etc net plan and go in here, and we want to change this to include under eth1, the routes that we want. Now, if we do IP route and IP-6 route, we can see that currently there's no references to the .2 subnet. We've got the only subnets it knows about are these ones. So once we've added those routes, we need to then do sudo netplan generate and then netplan apply. And once that's done, we can then re-look at our routing table, and we can see that to get to this .2 IP version 6 subnet, we need to go through interface eth1, which is this one here, and then to get to the .2, we need to go via this gateway here. So that's very explicit in what we're saying to it. So now we've got the routing correct. The firewall knows to forward everything correctly out this interface instead of trying to send it out the wrong interface and then hitting the wrong gateway and all sorts of stuff going wrong. So that then is our getting another subnet working. We also have here, if we do this and then we do game with Google, we still have an issue here, but let's have a look at just IP version 4. Doesn't seem to be, and I'll just explicitly say it's IP version 4. And we're not getting anything coming out as well. So we certainly, once you start making these changes, you've got to make sure that every single thing that's a problem, so we go to 4, so we might do this one as well. And we want to say, I want to masquerade that subnet, and I want to certainly, oops, visual, yes, P, and 7.4, let's make sure we get that right. And we want to get our dev, whoop. We want to get our dev it seems to be a bit slow, I don't know why. So we want to go our IP version 6 through our dev box, and just want to make sure that we pop this in correctly. So that's making sure that our IP version 6 is working. Now what will happen is we try and get this working, and we can see that it's pinging, but when we try and connect via IP version 4 or version 6, it's not working. So again, we can just use a show added and then find a rule that's close. So we want to say, and this is just allowing everything from a specific subnet. So everything from the dev subnet going in the eth1 interface and out the eth0 interface will be allowed on version 6, and we can do the same thing on 10.82.2.0.24, and in theory that should now enable okay, so it looks like we're good. Yeah, so we're working on that as well. Now, one thing that you probably want to know is it performant? This is where you can do an apt-get install speedtest-cli, and so I'm just installing this in the dev machine. So the question is the Ubuntu file we've put in, is it quick enough? Is it going to have enough speed for us to maybe have a number of hosts behind it? So it's a good thing to know as part of testing, to go, oh yeah, it's doing pretty well. So what we can do is install speedtest-cli, and once that's finished installing, just test it. Let's have a look at while we'll wait for that. Show added. So we're getting a heap of rules, and I wouldn't be surprised if this dev machine is running out of, let's see if it is, 10.82.2.4. Yeah. So it's very possible that there's no more. Let's have a look at top. Free. Let's see if there's any. Yeah. So this machine I haven't got swap enable for it. So what we can do, let's do another one here. Go back up to the top here, and we might just change this from swapfile to mount swapfile, and we'll just go next one. Just make sure it's all right. Let's give this a swap file, because it's probably the reason why it's not returning is it doesn't have enough memory. Let's have a look again. Yeah. So as soon as it gets a swap file, it swaps stuff out. So yeah, it might have just taken a little bit longer there because of that. So now what we're going to do is do a speed test, and now what's interesting about these speed tests, you do the first one, and then you think, oh, that's terribly asymmetrical, and then you run it again, and then you find that your different runs sort of get closer and closer to being more sort of even. But I think we can agree that that bandwidth is probably fine for any sort of testing that you might want to do, or so that gives you a way to verify that, yeah, you're getting a nice throughput through the firewall device, and you've got a reasonably useful working arrangement there. So let's have a look finally. So in the end, what are you left with? Well, you're left with a firewall that you can manage from the command line with reasonable bandwidth, but from on a very, very low spec VM. So that means that it will be quite cheap to run. So great for testing and doing whatever you need to do in Azure. So if you like this content, please like and subscribe.